Also, I can't really show you this because I did have a cigarette lighter and I've gone and forgotten it, but this is another smart material that you might have come across. Have you come across shape memory alloys? Yeah, you've done them in design. Again, these are again, they're classified as smart materials because once you bring them up against some form of energy, and in the case of this, it's heat, like the thermochromics, they will, you can bend them out of shape, and then when you heat them up to the temperature at which they were originally produced and extruded, all the kind of particles in the metal, so now I've bent them all out of shape and they're kind of lying around like this and leaning against each other, and then when you heat them up, they kind of all stand back where they're supposed to be, like soldiers. Oh, you've got a torch, great. So let's just show you this. Ta-da. So I'll put that down before I burn myself. And again, that as a kind of material is becoming much more readily available. It's used in things like, so you've got the Formula 1 on here soon, car racing. Some of these cars have brakes that work with these kind of materials, but instead of using heat, they use an electrical charge, so they send a pulse to these, which actually straightens out metal, which opens a brake. So certainly within engineering, in devices with buildings that need windows to open, some of these technologies are deployed. I'll send this round. Does your school have any kind of rapid prototyping at all?
Not yet.
Not yet? This is a nickel sintered sphere. So this has been generated by firing a laser into nickel powder. And it's one of the many processes for what's kind of under the kind of broad heading of 3D printing or rapid prototyping. And I'll just send that round and you can see how delicate it is. So if you can draw something, you can make it. This is a piece of 3D printed wood. So again, as you might imagine, there's 99% wood, but there's 1% sort of plastic glue. And when you mix them together, you've got a meltable material that can go through a glue gun, and the glue gun is kind of used on a computer to print an object. And somebody here, ironically, has printed a kind of root system for a tree. Now, again, you've got to ask the question when you're thinking of using a technology like that, why would you 3D print wood? You know, for centuries we've learned how to hone wood, to make things out of wood. We've designed tools to kind of, you know, bend wood, to fashion wood. I think one would only use it if you could make something, in a way, an object that you couldn't make in the way that we normally would make it. So maybe there's a time thing. And it's the same with lots of 3D printed things. I've just completed, you can pass that round, I've just completed a project with some designers from New Zealand. They're trying to print shoes. Now, why would you want to print a shoe? Anybody can...
Could it not be unique for one person, so you can fit it so it's perfectly fitted?
Absolutely. It's unique to you. It's a scan of your foot. So it's like having a suit made. Has anybody ever had shoes made to fit? I have to own up, I've made my own shoes. I did a shoemaking course. It took me 2 years and I handmade a pair of shoes. They were so nice when I put them on. I barely wear them. I can't wear them because I know I would wear them out. I made something that actually was just too good for me because I can't afford to have my shoes made. So now I kind of had them on a plinth. I just walk past them and dream about having my shoes made. So actually, to have shoes that fit you perfectly would just be amazing, because we've all got different shaped feet. So the kind of idea behind this project was to make a cheap, easy to follow, kind of accessible process so that people could have their shoes made. So I worked with a designer, and their big problem was a lot of the materials used in 3D printing, they're not very durable. Because actually a lot of the things we wear on our feet, they're never really made of one material. They're made of like these combinations. They're hybrids. They're kind of things that kind of are conjoined. So what we did was we printed, these are his feet by the way, he's got big feet. We scanned his feet, and then he designed these different matrices, and each matrix has a different sort of give depending on what the shoe's for. You know, if this was a work shoe, we wouldn't have it flexible like a running shoe. And so with the scan of his foot, he can wrap these different matrices round. And then what we did is we dipped these, hence my, my clip I've got here, we dipped them in different types of cold curing rubber. And then we did lots of tests like engineers do to see if they would bend and how durable they were, how flexible they were. So there's some quite exciting things happening in that technology, which isn't just about kind of finding a way to you know, obviously create a market and make lots of money. There's interesting ways in which this kind of technology is about helping people to get things that are absolutely perfectly fitting for them. I think this is a good demonstration as well. These two objects are printed in the same material. One of the objects is very hard, and I can show you if I bounce it. It didn't sound very hard, but it is, I assure you. Oh, that sounds harder. And this one is very soft. The reason being, inside the print, this has been designed to have like leaf springs, which used to be the spring on the back of cars' axles. So actually what you print inside an object in terms of the matrix will give you the way the object responds. So you can print a soft object and you can print a hard object in the same material. So again, people are learning more and more about how you work with these systems. And I'll show you one last material before I show you another piece of work. This is a piece of 3D knitted foam. So this is a textile. Now, about 20 years ago, the automobile industry in Germany, they got together. Their biggest pollutant was foam out of car seats, because once it had gone through its lifespan, it would be torn out and it would just end up in landfill. It gives off quite a lot of poisonous gases. It was very, very bad for the environment. So they wanted to try and kind of resolve that problem. And they came up with a plastic that was a biodegradable material. But as you might imagine, a biodegradable material isn't a foam. And some smart person said, well, let's knit a foam. So a bit like the thread that's made out of stone, you can make a thread out of a bioplastic, extrude it as a thread. The nice thing about this, and I'll pass it round, the harder centre, which is very thick, acts as the sort of spring, and the top area that's very soft acts as the comfort, but it's the same material but just at different thicknesses. So again, if you imagine very thick is hard and strong, very thin is soft and light. I'll pass that round. Because our program is an interdisciplinary program, he spent most of his time being a graphic designer for 2 years, but then in his final year he said, I want to invent a material. So because I'm the material person, he was sent to me. I have to get everybody who wants to do material things. Anyway, I said, Toby, have you ever invented a material before? He said, no. I said, well, you know when you're cooking and you're mixing things up? He said, oh, I don't cook. I thought, how are you going to invent a material? You don't cook. So I sent him home to bake bread, and then he came back very excited because he'd mixed flour and water and yeast and he'd seen what happens. And then he started to experiment. This material is 99% wood powder. And when you mix it with a bit of flour, which is glue, and a bit of yeast, and you put it in the oven, it rises and it bakes. And he made all these objects. This is one of his lampshades. When you switch the light on, it smells like you're baking bread. Which is amazing, because it's a piece of wood. So again, you know, these are like the experiments that you can actually create things, but you won't know what to do until you experiment, till you mix things together, till you try things out, till you see what happens to them. All right, I'm going to finish there. Thank you, everybody, for coming along. Good luck.
Okay, just very briefly, because I know you're off to lessons. As I said at the beginning, we know he comes from Goldsmiths. So, excuse me. So some of you that are thinking about where to go in university, what to do in your next phase, just remember that this is the place where those kind of creative connections are made, and you can adapt what you're learning into making graphic design. So it might be that it's a university kind of thing that you're interested in. Yeah, I know that some of you have probably come away with a sense of wonder about new materials, and it's not long before we've got a studio of making, which Mr. McNair's is making, in terms of some very smart materials, and obviously some of the things that we've been shown today, I think we'll get on the shopping list and get those. So it may be that you're fascinated with those materials, yeah? But I think I'd be really upset, and I know that Martin would be, if you went away not thinking about creativity. That sense of smashing opposites together. Things you hate, things you don't hate, yeah? Smashing wood and bread and glue and things together.
Anything.
So please don't leave the room just thinking, if only I think about smashing these crazy things together. Then we've potentially got 25 new students at Goldsmiths.
Always, you're always welcome.
And the latest guide to make $1 million out of silly putty. Yeah? Okay, let's give another round of applause.